Hi, and welcome to this tutorial on simple linear regression in R. Today we will see how to use R to understand and predict the relationships between two variables with a regression model. At its core, simple linear regression is a method used to predict the value of a dependent variable, also known as the outcome or the response variable, often denoted as y, based on the value of an independent variable, also known as the predictor or the explanatory variable, denoted as x. Importantly, the model assumes a linear relationship between these two variables. As x increases or decreases, y does so as well in a linear way. This relationship is represented by the equation where m is the slope of the line and b is the y-intercept. Let's assume we have sales records and marketing budget data for our product. The slope of the line represents the average change in the dependent variable y for a 1 unit change in the independent variable x. In simpler terms, it tells you how much sales are expected to increase or decrease if M is negative for every additional dollar spent on marketing. The slope is a crucial part of the equation as it quantifies the strength and direction of the relationship between the two variables. The y-intercept of the line, which is the value of y when x is 0, represents the expected value of the dependent variable when the independent variable is absent or 0. In our marketing and sales example, B would be the expected sales when no money is spent on marketing. So how do you calculate the regression equation? In practice, you don't manually calculate the values of M and B. Instead, you use statistical software like R, which computes these values based on the data. The process involves statistical methods that minimize the sum of the squared differences between the observed values of y and the values predicted by the regression line, a method known as ordinary least squares. In R, the LM function, which stands for linear model, takes care of this complex computation, utilizing the ordinary least squares method to compute the best fitting line through your data. Let's go back to our example with the sales and marketing data. This dataset contains historical data on the amount spent on marketing in thousands of dollars. This is the independent variable x, and the sales generated in millions of dollars. This is the dependent variable y. Before running the regression, it's good practice to visualize the data to get a sense of the relationship between marketing spend and sales. This plot will give you a visual idea of whether a linear relationship exists between the two variables. In our case, we can see clearly that the relationship between marketing spend and sales is best represented by a straight line, so we can proceed. Now let's use the LM function to perform the analysis. The summary output will provide you with several pieces of important information: coefficients, residuals, and R squared. This section shows the estimated values of M, slope, and B, intercept. For our model, M corresponds to the coefficient of X, and B is the intercept. These are the differences between the observed values and the values predicted by the model. Summary statistics of residuals can give you an idea about the fit of the model. R square. This value indicates how well the independent variable explains the variation in the dependent variable. It ranges from 0 to 1, where a value closer to 1 means better fit. The output gives us an intercept of 3.3 and a slope of 0.05. This means for every $1,000 increase in marketing spend, sales are expected to increase by $0.05 million or $50,000, assuming the relationship between these variables is perfectly linear. The intercept value of 3.3 suggests that even without any marketing spend, the sales would be $3.3 million, possibly due to existing brand recognition or other factors not accounted for by marketing spend alone. With our model, we can now predict sales for a given marketing spend. Let's predict sales for a marketing spend of $200,000. Through this example, you can see how simple linear regression in R provides a powerful way to understand and predict the impact of changes in one variable on another. By analyzing historical data, businesses can make more informed decisions about future investments in marketing and other areas and achieve greater sales outcomes. This process Visualizing data, modeling relationships, interpreting results, and making predictions is fundamental to data driven decision making in various domains. Next time, we'll continue exploring regression modeling and learn how to check regression assumptions, assess model fit, and diagnose potential issues. Thanks for watching and happy coding with R.